In this video, we're going to talk about the branches lab. This is the first lab that we are going to do outside of Xi Labs. So to start, we're going to go into Blackboard, go to our learning modules, go to the branches learning module, and the very last item in there right now is the branches lab. We're going to need to download all of our .java files and our branches lab write-up. All the instructions, specifications, grading, submission, all of that is in the branches lab write-up. So definitely go through that pretty carefully. But you're also going to want to download all of these .java files, I recommend, into a single directory. To do that, you can right-click and say download linked file or download linked file as and specify a directory. If at any time you're reading the lab write-up or you're downloading the Java files and something doesn't look right or something doesn't seem right, the code's not matching up with what the description is given in the lab write-up, please email me or post to the discussion board. Unfortunately, I make some mistakes with this stuff too, and I really don't want that hindering you guys. So if anything doesn't seem to smell right, just email me or post to the discussion board right away, or talk to me in an office hour. Okay, so we've got all of our files downloaded. We're going to go ahead and open Dr. Java. For me, this is clicking on a jar file on my desktop. For Mac, it might be different, or sorry, this is Mac, but for PC, it might be very different. Okay, I'm going to close all the files I had open, and then I'm going to go ahead and say File, Open Folder, and I need to specify the template folder because this is the directory where I have all of the .java files sitting. And it's kind of a nice feature because all of the files open up right away. Okay, so a couple things about Dr. Java while we're here. So when you want to compile your code, you can just hit this button up here, and it'll compile everything that you've opened up. When you go to run it, you might get this error. Static error, this class does not have a static void main method accepting string square brackets. Okay, so what's going on here is we've selected a file that doesn't have a main method. That's really what it's saying. And because there's no main method in it, the Java virtual machine doesn't know where we need to start running our code from. So to fix this, we need to select a file that does have a main method. And so now if we select game.java, which is the main method for our game, it's residing, we go ahead and run, and now we get this ever so lovely window with a couple of interesting shapes in it. Also, now that we've gone ahead and compiled something, we have another tab that shows up here at the bottom of Dr. Java saying compiler output. So compiler output shows us that the compilation was successful, which is good. It also allows us to select a compiler. We want to be working in JDK 8.0 for this class. So if something else is selected and you're having issues, make sure that this is highlighted to 8.0. We also have a console tab, and the console tab is going to show you exactly what the JDK is, sorry, not the JDK, but the Java virtual machine is outputting. So when we tried to run something and it didn't have the main method, that's where we get this error. And that's actually really kind of what Java is doing. Now, Dr. Java has this nice little interactions tab that's also built in. And this interactions tab is sort of the console with a bunch of extra little features thrown in. You can actually do some nice little practices of Java, like you can declare variables here. And then I could actually print that out. And see, I get 10 printed out. So if anybody's ever worked with like a scripting language like Python, this is like its interactive shell. Okay, let's talk about what you need to do for this lab. So again, let us compile and run. So we get this lovely little window with a couple of strange shapes in it, and this is our game. Probably not gonna win any awards at GDC, but somewhere to start. Let's talk about the coordinate system we're dealing with here. This particular GUI windowing framework has a coordinate system that calls the top left corner here 0, 0. And then to go to our right, we are going to increase our x value. To go to our left, we'll decrease it. To go down, we will increase our y value. And to go up, we will decrease our y value. And that may seem a little counterintuitive, but that's how this system is set up. So what we want to do is take keyboard input when like W or H or 7 or whatever gets pressed. We want to be able to see what keystroke the user did, and then based off of that, move our flower player and move it in those ways I just talked about. Left, right, up and down in the plus or minus X or the plus or minus Y directions. So we'll start by looking at gamekeyprocessor.java. And this file, we have this process method, which the argument coming into it is this integer keypressed. And you can go ahead and use keypressed like any other variable that you've defined in the method, in your code. So you can use it just like you'd use X and Y here. So based off keypressed, you're going to switch and try to figure out which key it is. If it's W, you're going to go ahead and move your player up, and you would do that by setting your X and Y values. And in the case of W, for example, you're going to set your X and Y values to 0 and -5, because we're going to move our player up a -5 pixels when we get W pressed. Once you get your case switch statement, or switch case statement, however you want to say it, in there, you can try it out with the game. But to do that, you'd actually also need to modify player.java. And what you would have to modify here is this needs to become top left corner plus change in X plus top left corner for Y plus change in Y. Okay, so you can kind of just go ahead and do that blindly. Once you do that, you can recompile the code and try moving around our character. Now, one thing to do to remember though is you have to go ahead and change this back to position underscore X and position underscore Y so that the next part of the lab works. Okay, so we've got our player moving around. And it's going to make me recompile. So let's say now we've got our player moving around with our keys. You can actually keep playing the keys and pressing W so many times that your flower will go up out of the viewing space, out of the renderable space. And that might be pretty confusing to the player because they might not know how to get it back into the play space, back where they can see it. So what we want to do is clip the movement of our player. So we're processing all those keystrokes and we're moving 5 pixels at a time, but we want to make sure that when we're doing that, we're not actually moving outside of the viewable area. That is where player.java comes in. And there is a method in player.java called clip movement that takes in some parameters. And I go ahead and I've declared a bunch of variables for you here to try to make it easier for coding. We have top left corner X and top left corner Y. So these two variables actually represent the top left corner, just like it says, of our player. So this is what's kind of telling us where the location of our player is in the play space. And then we have width and height. And width and height are the width and height of the window that we're playing with. And then we have change in X and change in Y. And these are the changes. This is the change or the movement we want our player to actually make. We want it to move 5 pixels up or down or left or right. That's going to be contained in this change X and change Y. So based off all those variables, you're going to write up an if-else statement that makes sure our X and Y changes, like we were just talking about, in this case our position X and our position Y, never go beyond the bounds of our window, which will be, so they'll never be less than 0, 0, because that's our top left corner, like we talked about in our coordinate space. And they're never going to be greater than the width or the height, because if at any point that happens, part of our player will go off the screen and we won't be able to see it anymore. So that's what this function needs to do. And once you're done with that, you can go ahead and compile again, and you'll be able to move the little player around. The player shouldn't move out of a viewable space. And the other thing you can look at is this testbench.java. So if we run testbench.java, we get some printouts here on the console. If else test is true, case switch test is false. Well, testbench is hopefully to help you out a bit. It sets up a couple of test harnesses. That's what these are called. Test if else, test switch case. And these get called with these printouts. So what you can do, well, first of all, what is this? These functions are going to take parameters that our code can use to run, and then also take a parameter that we expect to see the code produce. So like our switch case we were talking about earlier, we take in a key. We're going to take like a W or a C or a D or whatever key, and we expect something to come out of that. We expect a point. And what point do we expect? Well, in the case of W, which is moving up, we expect to see 0 and -5. In the case of D, let's say we wanted to write out a case for D. We can just do that right now. We'll copy that code, paste it, try to line it up, try to line that up, and we can change this to D. And since D now is going to move us in the positive X direction, we're going to change this to 5, our X to 5, and our Y to 0. All right, I hope this helps. Good luck with your branches lab.